Welcome. In this lesson we're going to fix a problem with a settling glaze. And if you're not sure what that is, that refers to a ceramic glaze that does not stay in suspension. It settles out in the bucket and it's very difficult to stir it back up. Now here's the glaze that I've been supplied. So I'm going to go copy, and then I'll go into Insight, and we'll go Interpret Clipboard and go OK. Before going any further, I just want to explain a little bit further. A ceramic glaze is not a solution, it's a suspension. In other words, it's a bunch of rock powder stirred up in water, simplistically. And normally that rock powder should not stay in suspension, it should sink to the bottom immediately after you stop stirring. But because glazes contain clay, the clay holds all of the other powders in the mixture in suspension. But in order for that to work, you need at least about 15% kaolin, or 10 to 15% ball clay. Now if we look at this glaze closer, notice it has 2.5% bentonite, but no other clays. So obviously the problem with this glaze is that it does not have sufficient kaolin. Now before continuing, notice this line. Insight has put an asterisk here to tell us that it was not able to find this material in its materials database. So to figure out what this Frit is, I'm going to go to the Digital Fire Reference Library and search for Frit 4108. There it is. Now notice it says it's a low alumina, high CaO borosilicate Frit. But if we go down to the bottom here, notice it says that ferrofrit 3134 is an alternative. So I'm just going to specify that in the recipe. So we'll go back to Insight. For this, I'll go over here, type 3134, and click Update. Now notice that Insight has left the line label as Frit 4108, but it's looking up the chemistry of Frit 3134 for this line. So the question now is, how do I proceed? Now if you've watched the other lessons, you probably remember that in most cases I click this button and I click Copyright to make two copies of the same recipe, and then we alter the one on the right while comparing it to one on the left. However, in this case I tried that and it doesn't work. And the reason for that is there's not very much alumina in this glaze, and the little bit of alumina that, just to demonstrate that there's not very much, I'll go to a target, open a target recipe for cone 6 here, and if we look at the alumina, 0.25 is the minimum, and we have 0.23, so we're below the minimum. And if I click this button right here, it'll show me which material in the recipe is supplying the most of alumina, and it's soda feldspar. Obviously potash feldspar is going to be giving a similar amount as well, but there will be almost no alumina coming from any of these other materials. Let's just take a quick look at this Frit. I'll double click that. Now the reason Insight is a bit slow here is because I'm using a screen recorder to make this video, and it's eating up my microprocessor cycles. But anyway, you can see here that this Frit has 0 alumina. And so the feldspars are the only two materials that are supplying the alumina. So I'm going to have to pretty well completely remove those two feldspars and start from scratch in supplying the boron from this Frit. But I also need to use another Frit because I'm not going to be able to get enough sodium and potassium from just this Frit. So I'm going to start from scratch. So to do that, I'm going to click Recipe 2. First thing I'll do is choose No Unity. Whenever we build a recipe from scratch, we always do that when we use the Supply button. So to start, I've got the Frit 4108 line selected, and I want to source boron from it. So I'm going to click the Supply button, click Boron, and click Done. So now you can see our boron is matched up. Now to get now it has supplied some of the KNaO that I needed. Notice that I've got them combined in this checkbox because I'm not going to be able to probably not going to be able to supply them both individually, match them up, but I will be able to match them up as a total. So to supply KNaO, I'm going to introduce another frit, but the question is which frit? I want a frit that has a lot of sodium and potassium and very little or no boron. So I'm going to click the MDT button here to see Insight's materials database, and we are on the frits right now because we were looking at frit 3134 a minute ago, but I can look at all the ones up and down this list and look at the amount of boron and the amount of alumina, but I already know that in frit 3110 that I've got almost no alumina and only a tiny amount of boron. Now there are other frits that I could find possibly that would have no boron, but it would be difficult, so I'm going to use this one. Notice it has lots of sodium and potassium as well. So we'll close this dialog, and I'll put frit 3110 in this line, click update, and then click supply. And we're getting sodium and potassium. Now I can't select both of these, so I'm going to select the greater amount and click done. So if we go down here, notice that I've got 0.24, but I need 0.32. So I'll just simply go over here and start increasing the amount and watching this KNaO line as I do that. And I'll keep going up until I get to 0.32. But notice that in supplying that, I have overshot the boron. So I'm going to have to juggle the amount of these two frits a bit. So I'm going to go to this frit 3134, take it down. Notice I'm going by 2 at a time here. I'll go down to 0.2. Maybe I'll just undershoot it a bit. Then I'll go back over to the other frit, increase that till I get back up to my, and there we have it. I'll maybe go once more, twice more, there. Now if I was really being precise here, I could match these up perfectly, but we don't need to do that right now. But we've got them 0.33 and 0.32, 0.2, 0.2. Now, next I'll supply the remaining amount of the CaO because I have some from the frits, and that'll be simple. I just go to the whiting or calcium carbonate line, click supply. It's already selected CaO, and I'll click done. So we've got that. Now barium, I'll go to the barium line. Again, click supply, click done. That's matched up. Now the only ones left to match are alumina and silica. Now notice the alumina is 0.03, so it's very low, so I'm going to be able to supply all of that up to this 0.23 amount using kaolin. So let's do that. I'm going to use EPK, which is, according to my own experience, a kaolin that suspends glaze as well. Click update and supply, choose alumina and click done. There we have it. Our alumina is matched up, and now I just need to match up the silica, and of course I'll do that with silica powder. Click supply, click done. Now we have it all matched up. Now because I have been working in no unity, notice that the total of my new recipe is 347. So obviously I want to retotal that. I'm going to retotal it to 100 because the old recipe was 102.5 because of this 2.5 added bentonite. You'll notice also that I should mention that in the old recipe there was some copper carbonate and some tin. I've ignored those because I just need to match up the base glaze. Those can be added later. So we'll go back to Insight, and I'm going to choose retotal recipe to 100. Yes. Now notice we've got 15.96% kaolin, 16%. So that should suspend the glaze fairly well. Many fritted glazes have 15% kaolin. If a bit more suspending power is needed, a little bit more, a couple of percent bentonite could be added, and that should do the trick. Now if we go down and look at the formula again here, you can see now the numbers don't match after the retotal. So the reason for that is I still have it set at no unity. If I set it back at RO unity, now we're matching again. Also, before ending, I want to point out that normally people don't think that glaze chemistry is useful when we're talking about the raw properties of a glaze, the way that the glaze slurry works, for example. But as you can see here, it's very important, because what we've been able to do is create a different set of materials to source the same chemistry, and that set of materials has physical properties that are better than the initial set of materials. So obviously chemistry is very important. Second thing I want to point out is normally when we do major surgery on a glaze like this, it is good to see if there's any other problems in the recipe that could be solved at the same time. Now, obviously there's a lot of controversy about using barium carbonate in glazes and whether it's leachable and all these things. I don't want to discuss that here, but barium carbonate powder by itself is not the safest thing in the world to use. So if you could find a barium sourcing frit that also had low alumina, then it might be possible to work that into this recipe and solve that problem at the same time.